Hello everyone and welcome back to Diksha Karnataka YouTube channel, and you are watching second PU midterm revision of physics chapters. We have already completed two chapters, first two chapters. Today I am going to discuss about the third chapter, current electricity. It is a very important chapter. Okay, you can predict some of the questions even, so it is a very important chapter. If you study it properly, you can score a lot of marks from this. Okay, in terms of weightage also it is very important. We will see everything. So without any delay, let's start with current electricity chapter. Let's look into the marks distribution of the chapter. There will be one MCQ from this chapter, no fill in the blanks, according to the three different blueprints shared by PU board. So there is only one MCQ from this chapter, and in two cases the MCQ will be HOTS question, that is little difficult level question, and in one case it may be a remembering based question. So either it will be very difficult MCQ or it will be easy MCQ, but nothing in between. But don't worry, even HOTS MCQs is answerable. Okay, if you read the questions properly, we will see that very soon. Then there will be essay type questions, short answer type questions, one remembering or understanding. In one of the question paper there is a short answer type questions for 3 marks as well, but mostly this is not going to come. This is definitely going to come, this is definitely going to come, and in the all three blueprints you will be having 5 marks long answer type questions, that is theory questions, and one numerical question. Okay, but remember that numerical questions from this chapter is little bit tricky. Okay, you have to remember some formulas, some applications, Kirchhoff's laws, etc. So if it is a difficult question, you can skip the numerical question from this chapter. We will see some easier numerical questions in future, but for now I will discuss all the questions including numerical questions. So if you are having difficulty in any of the concepts, that will be clear during our discussion. And as we are doing, we are taking up the questions from your previous year question papers as well as the question papers given in your blueprint. So get ready. We will start with MCQs. First MCQ is the resistivity of metals increases with increase in temperature. Is it correct or not? First let us understand this. Statement 1, it is given the resistivity of metals increases with increase in temperature. As we know, if we increase the temperature, the resistance increases. So this is a correct statement. This statement 1 is correct statement. Number 2, increasing the temperature of metals causes more frequent collisions of electrons. Okay, as the temperature increases, the electrons are getting more agitated, they are tend to collide more often. So this is also a true statement, this is also a correct statement. Okay, so vibrations increases, we know that, right? So they are frequently colliding. Now let's see what is the options given. Both 1 and 2 are true, and 2 is the correct explanation of 1. Now let us see, is it the correct explanation of this? So as the temperature increases, okay, the collision increases. Collision increases, that means the electrons move slowly. So electrons move slowly means the resistance increases, the resistivity increases. So basically yes, statement 2 is the correct explanation for statement 1. So correct answer is option A for this question. You can check other options for statement and reason based questions. As we know, if we find the correct problem, correct case, then we do not need to read other portions. All the other portions you can ignore, right? So let's move on to the next question. Question number 2. Identify the wrong statement from the following. So you have to identify the wrong statement. So out of the 4 options, 1 option is wrong, 3 options are correct. So let's see which all are correct. The drift speed acquired by free electrons per unit electric field is called mobility. Yes, mobility is defined by drift velocity divided by electric field. So drift speed or drift velocity, whatever they are saying drift speed, because it is they are trying to tell it is a scalar quantity. So drift speed acquired by free electrons per unit electric field is called mobility. Yes, it is a correct statement. Don't get confused about term drift speed or velocity, both are same. Now let's look into the second statement. The conductivity of semiconductors decreases with increase in temperature. So conductivity decreases as we increase the temperature. That is true for normal metals, normal conductors. For semiconductors, it is exactly opposite. If you have studied that chapter, you know that as you increase the temperature, the conductivity of semiconductor increases, not decreases. So this is a wrong statement. Definitely this is a wrong statement. So we have found our correct answer for this. This is the correct answer. Here semiconductivity of semiconductors decreases with increase in temperature, which is wrong. So this is the correct answer. But now you might say, sir, I have not studied semiconductor. How I am be able to answer this question? Don't worry. Check other two options. Okay, what is the other option? Conductivity of conductors decreases with increase in temperature. For normal conductor, as I said, as we have seen in our previous question, as you increase the temperature, conductivity decreases. So this is the correct statement. Okay, alloys are widely used in the construction of standard resistors. This is also a correct statement. Okay, we know that nichrome chromium alloy, different alloys are used in case of resistors when we are constructing resistors. So this is also a correct statement. So only incorrect statement is this. Okay, and once you have completed the entire syllabus, this will be a very easy question to answer. Now let's move on to the question number 3. A wire has a non-uniform cross-sectional area as shown in the figure. So non-uniform means here, as you see, the area is less here and area is more here. Okay, so here the area is more, here the area is less. So A is less, B is more. Okay, a steady current I flows through it. A steady current I is flowing through it. Okay, which one of the following statement is correct? So now you have to understand which of the statement is correct. Now let's see what are all the options. Drift speed is of electron is constant. The drift speed of electron increases while moving from A to B. The drift speed of electron decreases while moving from A to B. The drift speed of electron varies randomly. So basically all the options are about drift speed. So you have to find the relationship between current and drift speed. So what is the relation? You have to remember that current is given by N E A V D. Okay, so here VD is drift speed, A is area, E is charge of an electron, E is the number density of electrons. Okay, now charge per unit volume. Okay, so this is the formula that you have to remember, NEAVD. Okay, so from there you can see that with drift speed is equals to I divided by NEA. If you remember this equation as well, that is also fine. Whatever equation you remember, I tend to remember this equation well than this. So I remember this equation. From here always I try to find the drift speed. Okay, if you are very familiar with this equation and you are ready to remember this equation, that is also fine. Whichever is fine for you is fine for me, but that varies from person to person. But you have to remember one of these forms, at least one of these forms you have to remember. Okay, now what is the relationship between I is constant? Okay, number density is constant, charge of an electron is universal constant. So we can say that drift velocity is inversely proportional to area. So drift velocity is inversely proportional to area. More the area, less the drift speed, drift velocity, less the area, more is the drift speed, right? So here, as you can see that area is less, so for A the area is less, for B area is more, so drift speed should be higher here. So drift speed will be higher here, and as we are moving, so as we are moving from this, so this will be decreasing. This will be decreasing as we are moving towards the bigger area. Okay, more the area, so this will be bigger and here it will be smaller. Okay, so bigger we can write it with a bold VD, and lesser we can write it with a smaller VD. Okay, so as we are moving from A to B, the drift speed decreases, right? So while moving from A to B, the drift speed of electron decreases. So correct answer is option C. Okay, decreases as you are moving from A to B. Be careful. Okay, if they reverse the option B to A, then in that case, if the current is moving from B to A, then the drift speed will increase. Okay, this is a tricky question, but not very difficult. If you remember this equation, remember this relation, answerable to you. Now question number 4. the resistivity of a metallic conductor dash with decrease in temperature. Again the same resistivity again, and how it varies with temperature. So this is a very important question throughout the year. So this question is very likely to come in your midterm as well. So one of those questions, so how the resistivity is dependent on temperature. Resistivity for normal conductors, normal metals, as you are increasing the temperature, resistivity increases. As you decrease the temperature, resistivity decreases, right? So resistivity as you are increasing the temperature, sorry, here it is decreasing the temperature. So you decreasing the temperature, resistivity decreases. Okay, so as you are decreasing the temperature, resistivity decreases. As you are increasing the temperature, resistivity increases. That is, it is more resistant, right? But it is exactly opposite for semiconductor. For semiconductor, if you increase the temperature, resistivity decreases. Okay, semiconductors are opposite to that of normal conductor. Okay, now Kirchhoff's junction rule is a reflection of, what is the meaning of this question? So what is the basic fundamental principle behind Kirchhoff's junction rule? That you have to be careful. Now there are two rules of Kirchhoff's junction rule, that is current, and Kirchhoff's node rule or Kirchhoff's voltage law, which is about voltage drop across different parts, or loop rule you can say. So Kirchhoff's loop rule is based on conservation of energy, whereas Kirchhoff's junction rule is based on the conservation of charges. Okay, so be very careful if they ask you this question. Kirchhoff's junction rule is based on conservation of charges. Kirchhoff's loop rule is conservation of energy. So by closing your eye, don't mark conservation of energy, it is conservation of charges. Charges are also conserved, right? We have learned that in our previous class, right? So this is the correct answer, conservation of charges for junction rule. If the same question is asked using the form that Kirchhoff's loop rule, then you have to be careful and you have to answer conservation of energy. Okay, now next we will answer short answer type question, but this chapter, as this chapter is not so important for fill in the blanks question, so I am not going to discuss fill in the blanks question for this chapter. Okay, I will go straight towards 2 marks question. Now one question with 2 variations, both questions will be answered in one go. Okay, so basically you can say this is not only one question, this is actually 2 questions. Define drift velocity and mobility of free electrons in conductors. Okay, so they have asked you to define drift velocity and they have asked you to define mobility. Okay, so it is very difficult. Most of the books, even in your NCERT book, if you are studying, the definitions are not properly written. So you have to be careful. What is drift velocity? Drift velocity is the average velocity with which the free electrons drift under the influence of an electric field is called drift velocity. So first of all, what are all the important terms here? Average velocity. Okay, average velocity with which free electrons drift, or you can, if you forget the term drift, you can say move. Okay, under the influence of an external electric field. In the presence of an external electric field, you can change the language, but these terms are important. These terms has to be in your definition. Average velocity of free electrons with which when in presence of an external electric field is called drift velocity. Okay, mobility is a little bit easier. The mobility of free electron is defined by the drift velocity of the electron per unit electric field. So mobility is basically, you can say mobility is drift velocity divided by electric field. Okay, if you remember this equation, you can write the definition. Now there are sometimes they will ask you define mobility only and mention its SI unit. Okay, so if they ask you that, then you have to start from this point. Okay, if they ask you only drift velocity and mobility definition, answer is over. But if they ask you define mobility and mention its SI unit, so then in that case mobility is this and its SI unit of electron mobility is meter square second inverse volt inverse. Okay, or meter second inverse Newton inverse Coulomb. Whatever you are comfortable with, this unit directly comes from this. Okay, and if you break down Newton, Okay, Newton is not a single unit, it's a complicated unit, right? Kilogram, meter per second square, etc. So if you break that down and combine it with volt, then you will get this unit. Okay, whatever unit is comfortable. For me, this unit is easy to remember because this is directly coming from the formula. Okay, drift velocity's unit is meter per second, and electric field unit is Newton per coulomb. Okay, so if you do that, you will get meter Newton, okay, sorry, meter coulomb divided by Newton second. Okay, this is also fine, or meter coulomb Newton inverse second inverse. Okay, this is also fine. Okay, this is the same thing is written here in a little bit different order. So even if you forget the formula, you can still remember the formula, you can still remember the unit by remembering the formula. Okay, now let's move on to the next question. Mention two limitations of Ohm's law. Very interesting question. Sometimes it might be coming as a 3 marks question, so I have added 3 options for this. Okay, but if they only ask you to mention 2, you need to mention only 2, that is fine. Okay, what are the 2? First of all, you need to remember the Ohm's law. Okay, so Ohm's law states that if temperature and other physical conditions remain same, then V is proportional to I, right? So that was the Ohm's law statement. So first of all, so basically what are the 2 conditions that should remain constant? First of all, temperature and other physical constants. Okay, other physical conditions. So first of all, so basically if all the physical conditions remain same, then only Ohm's law is applicable. If any of the physical condition changes, then Ohm's law is not applicable. Okay, so Ohm's law is applicable only if all the physical conditions remain same. Now what is the meaning of these physical conditions, in case you forget this point? So that's why I am helping you to remember what is the meaning of physical conditions. Physical condition means, suppose you have a metal through which you are allowing the electric current to pass. Suddenly, when the electric current is passing through it, there is a slightly heat is developed and the wire melts. Okay, if the wire melts and becomes liquid, then the Ohm's law is no longer applicable. So physical condition means physical states, solid, liquid, gas. Okay, so based on what the condition of the material, okay, sometimes material might be, there may be some chemical reaction happens. Okay, for example, if you take 2 electrodes and if you put it into water, hydrogen and oxygen will separate from each other. So chemical reaction will happen. So this is not, the physical conditions will change. So in that case, Ohm's law is not valid. So any one of the physical condition, if it changes, then Ohm's law is not valid. Okay, so this is the basic meaning of physical conditions. If you forget that, that's why I help you with some examples of physical conditions. So remember, state, chemical reactions, they are basically violation of Ohm's law. Next, what else? Ohm's law is not applicable for very low and very high temperature. So basically, if you remember, other point was that if temperature and other physical conditions remain same. So if temperature is changing, then Ohm's law is not valid. In fact, at very low temperature, absolute zero, close to absolute zero, and at very high temperature, when the temperature is thousands of degrees, for example, the temperature of sun, in that higher temperatures, Ohm's law is not valid. Okay, so Ohm's law is valid only in and around room temperature. Okay, whether room temperature is moderate, so around that temperature range, Ohm's law is valid. Very high temperature, very low temperature, Ohm's law is not valid. Okay, Ohm's law is not applicable to non-ohmic devices like semiconductor devices, discharge tube, etc. So this is one of the extra point that you can remember. In case you forget one of the 2 points, then you can add that Ohm's law is not applicable for non-ohmic conductors such as semiconductors. Okay, PN junction diode. If you have studied PN junction diode, you can add that as well. Okay, so for diodes, triodes, transistors, etc., Ohm's law is not applicable. Okay, this is one of the handy example that you can remember. To even if you forget the 2 points, you can write this point to get full marks. Or if they ask you 3 marks question from the same concept, that write down the 3 limitations of Ohm's law, 3 marks, then you can add this point and you can get full marks. Now next question. Okay, this is from your sample paper, model question paper. Give any two differences between current and current density. Okay, this never came in the previous year questions, but this is directly taken from your model question paper, so might be coming to your midterm question, maybe coming to your final question as well. So first of all, how to write a difference. Okay, you know that difference, if they ask you to write the difference, basically if you can answer them in a difference table, it is very clean and soothing to the eyes, so teacher will can easily check your answer and give you full marks. Okay, and what else? First of all, you have to write the definitions in the first point. Second point, you can write the unit of these two quantities. Okay, so this is the basic two differences. Okay, first of all, current is basically defined by, if you remember, current is defined by Q by T. This is the basic definition of current. Charge per unit time, charge flowing per unit time. Current is defined as the amount of flow of electric charge per unit time. Okay, so this is the basic definition of current. What is current density? Current density is the amount of current per unit area. Okay, very important. Unit of current is ampere. Unit of current density is ampere per meter square. Okay, or m to the power minus 2. Now, last year there was an objective question based on this formula. Okay, so they asked you what is the unit of current density. Most students wrote it wrong. Some students wrote it ampere per meter, some wrote ampere per meter cube, but actually it is ampere per meter square. Okay, current per unit area. So that is the unit of current density. That is actually helping you to answer one more objective question as well, if they repeat the question in your midterm maybe. Okay, now let's move on to the question number 4. Name two factors on which the resistance of a metallic wire depends. Now we know that resistance of a metallic wire is given by rho L by A. Rho is resistivity of the material, okay, L is the length of the material, A is area. Now if you say that, okay, this is a single material, so resistivity is constant. Okay, so resistivity is constant. That means what else? Resistance is directly proportional to the length of the wire. Okay, so you can write this in words also. Okay, resistance is directly proportional to length of the wire. Then in bracket you should write R proportional to L. Okay, that will give you 100% chance to score full marks. What is next? Resistance is inversely proportional to the area. Okay, that's it. You don't need to explain. 2 marks question, explanation is not required. Okay, only thing that is important, you answer them perfectly. Resistance is directly proportional to the length, that is R proportional to L. Okay, resistance is inversely proportional to the area, that is R proportional to 1 by A. Okay, and if you are smart, you can add this equation as well. Okay, so teacher will think, okay, he knows a lot. Okay, your impression to the teacher will improve and you will get a good marks. Okay, in fact, if you make small mistakes, he will ignore. Okay, fine. Okay, now question number 5. Write the expression for drift velocity in terms of current. Explain the terms used. So I have already done in one of the questions that I told you. I remember the formula like this: I equals to NEAVD. Okay, this is how I remember. Now here they have asked you to write drift velocity in terms of current. So from this equation you can see that Vd equals to I divided by NEA. Okay, so now you have to explain the terms. So first you have to write drift velocity. Okay, next you have to explain the terms I equals to current. Okay, N is equal to number density of electrons, E is charge of an electron, and A is the area of the wire or conductor. Okay, so this you have to do, and only for writing these much you will get 2 marks completely. Okay, now Next question, this is only one 3-mark question I have chosen. This is from your one of the previous year question. So but only one question paper has this 3-mark question. For your midterm question, possibly one 3-mark question will come, but for your final question there is a less chance of coming 3 marks question from this chapter. There are other chapters from where 3 marks question are more likely to come. Okay. Now derive the expression for drift velocity in terms of electric field and relaxation time. So to start the answer, you have to draw this circuit, this diagram. Okay, there is a battery here, there is a conductor here, electric field is applied in this direction, an electron is moving in this direction. Okay, this is the basic thing that you have to draw, a very basic picture. Now what you have to do? So first of all, what is the force acting on this electron? So electric field is applied in this direction, electrons are negatively charged, so they will drift opposite to the applied electric field. So the force on an electron is given by F equals to minus EE. We know that force equals to QE. Right, yesterday we discussed force in an electric field on a charged particle. So Q charge in an electric field, if you keep it on electric field, the force acting on this charge is given by QE. Remember that. Here the charge is negative and it is electron, so that's why this negative sign is coming. Okay, negative sign indicates that the force is acting opposite to that of the electric field, nothing else. Right, so force on this electron is this. Now what is the acceleration of the electron? Due to this force, the electrons will accelerate, right? What is the acceleration? So acceleration will be force divided by mass, right? F equals to ma, Newton's second law. Father equals to mother, father equals to ma, right? So put the value instead of F, E by m, or leave it. Okay, we don't need anything else. Okay. Now here you can do a lot of write-up. Okay, you can do a lot of write-up that is there in your book, but I am going to teach you a small shortcut trick for this question to get the full marks. From the definition of drift velocity. Okay, so what is the thing is that average velocity of the electron is known as drift velocity, right? So from the definition of drift velocity, we can write Vd equals to 0 u plus at. Okay, so a tau. Okay, here tau is the relaxation time. Okay, you can derive this formula. Okay, there is a long derivation is required, but for this question that derivation is not required. Only thing that you can write is from the definition. So when the time is equal to relaxation time, if you apply this equation V equals to u plus at formula, here initial speed is 0. Okay, then whatever the average velocity or whatever the velocity you will get, that is the drift velocity. As simple as that. Okay, so put the value of acceleration here. So Vd equals to minus E by m tau. Now they have asked you to find the drift velocity in terms of relaxation time. So this is the formula, this is the answer. You will get full marks within this diagram and this derivation. Okay, you will get full marks, but don't forget to write this line. If you are not writing this line, that means you have to do the entire derivation for this equation. It is there in your book, you can check that out. But I have seen students, I gave them shortcuts, they make it even more shorter. They start with F is equal to E and they write the second line and they write the final line. In that case, they will deduct marks. okay, your answer is not complete, your explanation is not complete. Okay, we are ready to give you some relaxation. Okay, he has not done this equation derivation is not super important, but if you know this, that means this is coming from the definition of drift velocity. Okay, so that is what important. Now remember that the same question might come, derive an expression for relaxation time in terms of drift velocity. So what is that? From this equation you have to calculate tau. Okay, so your final answer in that case will be tau equals to minus mvd divided by EE. Okay, this will be the answer. Okay, so if they ask you relaxation time, then this will be the answer. If they ask you drift velocity, this will be the answer. So be careful what is the question saying. So this is given in your previous question that find the expression for drift velocity, but in the midterm question or in the final question they will ask you find the relaxation time. You will think, okay, this is a different question. Same question, Baba. You have to look into the question, you have to read the question a little bit, right? Little bit, Salpa. Huh? Now next question, 5 marks question. 2 cells of, now from this chapter there are specifically 3 long answer type question that you need to study. Okay, and one of that question will going to be definitely coming to your board exam as well. Midterm, board exam, pre-board exam, everywhere out of these 3 questions, 99% chance, okay, 0.1% chance I am withdrawing for my own safety, right? So 99% chance one question out of these 3 questions will come. Every alternate year one of the questions is repeating and they are revising the questions. Okay, so for example last year it was expected that Wheatstone bridge will come, but cells combination of cells came and Wheatstone bridge was asked in a numerical question. Okay, so but this year most probably Wheatstone bridge will come, but in case for safety reason you have to prepare other 2 cells as well. Cells in series is very easy, cells is in parallel is slightly difficult. Okay, if the examiner decides to make the level of the question paper slightly difficult, then he will give you cells in parallel. Otherwise most likely for this year question paper Wheatstone bridge is more likely than any other question. So first we will start with cells in series, because we are not thinking about board right now, we are thinking about midterm. In midterm any one of the questions may come. Okay, there is no guarantee in midterm. I cannot give you guarantee in midterm, but one of the question will definitely come after your midterm is over. Okay, mention, come back to this video, mention in the comment below, did you get the question common or not? Okay, so we will see how many of you are getting this question common, one of the questions, one of these 3 questions. Okay, 2 cells. There are different questions from this chapter as well. So for example, prove that the expression for drift velocity, prove the mobility, etc. are there, but that is very rare. Okay, once in 10 years that question comes, so we cannot take the risk with that. So I am not going to discuss those questions. Okay, if you have time you can study those questions as well, but these are the 4 very important questions. Okay, so this is an important question. 2 cells of different EMFs and different internal resistances are connected in series. So 2 cells of different EMF and different internal resistances are connected in series. Suppose this is epsilon 1, this is R1, this is epsilon 2, R2. Okay, epsilon is basically the symbol for EMFs or symbol for voltage or battery. Voltage of battery is represented using symbol epsilon 1. Okay, now derive the expression for effective EMF and effective internal resistance of the combination. Very easy question. Cells in series, basically they have asked you to find the cells in series. Okay, for that you have to add one external resistance. Suppose this connection is combined thing is connected to an external resistance of R, and the current in the circuit in this case suppose is I. Okay, now the equivalent circuit, what is the thing of equivalent circuit? Equivalent circuit will have only one EMF. Okay, no matter how many cells are there, and the resistance will remain same, the external resistance will remain same in this case, and the current in the circuit will remain the same. Okay, so this is the epsilon equivalent, this is R equivalent. Okay, so our target is to find this. E epsilon equivalent and R equivalent. So first what we will do, the current in the circuit is constant, right? So we will apply Kirchhoff's current law. Okay, Kirchhoff's voltage law. What is the Kirchhoff's voltage law? We will move in the direction of the current. We will move in the direction of current and we will take all the resistors. All the resistors. What are all the resistors? First we will start with R. So R times the current. Same current is flowing everywhere, right? There is no other path. So same current is flowing everywhere. So R times I. Okay, now this is going through the R2 as well, plus R2 times I, and same current will pass through R1 as well, conservation of charge. So R1 times I. This is the all the voltage drop across all the resistances. That should be equals to the EMF attached in the circuit. Okay, this is the Kirchhoff's from Kirchhoff's loop rule. Okay, or we used to say KVL, Kirchhoff's voltage law. Okay, in your book, in your NCERT book, it is said loop rule. Okay, if you write KVL, that is also fine, Kirchhoff's voltage law. So this is the equation, or from here we can write that let's find the I. So I will be common, R plus R1 plus R2 equals to epsilon 1 plus epsilon 2, or I equals to epsilon 1 plus epsilon 2 divided by R plus R1 plus R2. This is the expression for current, right? Now what all we have to do? We have to find that this is not the answer. We have to find the equivalent EMF and equivalent resistance. So for equivalent circuit, okay, for equivalent circuit, if you see now, if you apply the KVL again, you will see that I is nothing but epsilon equivalent divided by R plus R. Right? Why? Total resistance, two resistances are in series. So total resistance is R plus R eq. So V is equal to IR. So from Ohm's law only we can write V is equal to IR. So from there we can write R equivalent is equal to R plus R equivalent. Right? All the resistances in case of EMF of cell, they can be considered to be connected in series. Right? So that's how we have solved this question as well. Now let's see, comparing, this is equation 1, this is equation 2. Now we have to compare. So what we can compare? If you compare, so in the numerator both cases the EMFs are there, and in the denominator both cases resistances are there. So we can compare numerator with numerator. So we can say E equivalent is equal to epsilon 1 plus epsilon 2. Comparing 1 and 2, epsilon equivalent is equal to epsilon 1 plus epsilon 2, and comparing the denominator R plus R1 plus R2 equals to R plus R equivalent, right? So from there we can again cancel this two values. So we can say R equivalent is equals to R1 plus R2. So this is the equivalent EMF. This is the expression for equivalent EMF and equivalent resistance. Okay, I hope you understood this. This is very easy. This is the easiest derivation of the three derivations that I am recommending from this chapter. So from this chapter, if you do this derivation and other two derivations, then you will be very good to go for your midterm question. Now derive an expression for effective EMF and effective internal resistance of two cells of different EMFs and internal resistances connected in parallel. This is the parallel combination of cell. Okay, so parallel combination means we have two cells. Okay, same thing. Okay, so this is slightly a little difficult. Okay, suppose this current is I1, this current is I2, this current is I, and the corresponding equivalent circuit will be same. Now the derivation is little bit difficult for this case. Okay, so here we have to take two different loops to find the values. Okay, first we will start with this loop. Let me name this loop. Okay, so A, suppose B, C, R, and this is D. Okay, so these are the points that we have to mark. So first we will start with this loop, A, B, C, R, A, this loop. Okay, the external loop. First we will start A, B, C, R, A, this loop. This is the first loop that we are considering. From loop A, B, C, R, A, right? So from this loop what we can say is that what are all the resistances? R1, what is the current through R1? Current through R1 is I1, because I1 current is exiting the battery. The same current has to enter the battery as well. Condition of conservation of charge principle. Also one more thing before going into that, let me apply junction rule, Kirchhoff's junction rule at point A. At junction A, I1 and I2 both are coming, and I is exiting. I1, I2 entering the junction, and I is exiting the junction. So we can say I equals to I1 plus I2. This is the first thing. Okay, that we have to mention it first. Next we have to use this junction. So now in this junction, what are all the resistances? First resistance is R, current is I through that, so IR. Okay, now as you are moving in this direction, the current is moving in this direction, so it will be positive, and I1 R1 plus I1 R1 equals to epsilon 1. Okay, so this is the first thing, right? Now what is the next we will have to take the second junction. What is the second junction? Second junction, let us consider this. Okay, A, D, C, R, going back to A. Okay, so this is our second loop. A, instead of going to B, we are going to D now. Okay, A, D, C, R, A. Okay, so only one point is changing. Now we are going in this loop. From this loop, what we can write, IR will be IR again, plus instead of I1 R1, it will be I2 R2, right? So I2 is going out, so I2 will come back as well. So I2 R2 equals to epsilon 2. Okay, simple. Now what we have to do, we have to find the current I. Okay, so to find the current I, we have to eliminate I1, I2, but that will be little difficult because you cannot calculate it directly. So what we will do, first from this equation we will find I1. What is I1? I1 is epsilon 1 minus IR divided by R1. Okay, and from this equation I2 will be epsilon 2 minus IR divided by R2, right? So now what we will do, we will use these two values in that equation. Okay, so we will use these two values in that equation to find I. So I is equals to, now you will see that I will also have a term I. Okay, so that's why it is little complicated. Otherwise, if somehow we were able to complete this derivation here only, it would have been easier. Epsilon 1 minus IR by R1 plus epsilon 2 minus IR divided by R2. Okay, so you can simplify this equation. Unfortunately, I am running out of space, so what I will do, I will keep these values here and remove this. Okay. Okay, I will write the values here. I1 equals to epsilon 1 minus I1 R1. By the way, you can download the lecture notes after the class is over. So if you are thinking that where I will get this, you can check our channel. In the description box, the class notes will be available. Okay, now what we have to do, we have to simplify this. So how we can simplify? First of all, R1 is in division here, R2 is division here. So what is the LCM? I equals to, LCM is R1 R2, right? So two different values, you have to multiply it, then this will be multiplied here and this will be multiplied here. Okay, so we can write epsilon 1 R2 minus IR R2, right, plus epsilon 2 R1. Be careful only. Okay, these steps are not difficult, only thing you have to be careful. Epsilon 2 R1 minus IR R1. Okay, now you have to do the cross multiplication. This will be multiplied here. So I R1 R2 equals to epsilon 1 R2 plus epsilon 2 R1 minus I R common, okay, R1 plus R2. Right, if you take this negative and IR common, it will be coming out to be R1 plus R2. Now take everything related to current on the left hand side. So what we will get? IR R1 plus R2, it will become positive because it was negative on the left hand side, plus I R1 R2 equals to epsilon 1 R2 plus epsilon 2 R1. Okay, so this is the basic thing. Now what we have to do, we have to simplify these values and take the I common. If you take I common and put the values, then you will get I equals to epsilon 1 R2 plus epsilon 2 R1 divided by R plus 1, sorry, R1 plus R2 plus R1 R2. Okay, we just need to take I common from here. So one step here, okay, R1 plus R2 plus R1 R2 equals to this, right? So you get this. Now if you remember, in the previous case we obtained the current for equivalent case is epsilon equivalent divided by R plus R equivalent, right? Now what is the obstacle to write this equation like this? Only obstacle is this value. See, R was single here. here R is not single, it is mingle. So what we have to do, we have to separate this term and we have to adjust such that it is no longer that. So for that what we have to do, we have to divide numerator all the terms using R1 plus R2. So our numerator will become epsilon 1 R1 plus epsilon 2 R2 divided by R1 plus R2, and denominator will become R plus R1 R2 divided by R1 plus R2. Okay, so this is the expression for current. From comparison we can write, by comparing we can write equivalent. This is epsilon 1 R2. I made a mistake here. It is epsilon 1 R2 and epsilon 2 plus epsilon 2 R1 divided by R1 R plus R2. This is the combined, right? And R equivalent will be equals to R1 R2 divided by R1 plus R2. Okay, so as the final expression is not super pretty for at least now, okay, if you are preparing for competitive exam, you can further simplify it a little bit more to get a more good looking expression, but for your board exam this derivation is sufficient. This derivation is sufficient. If you have done this derivation, just write step by step equations. Okay, first start with I1, find I1, next find I2, then you know that I1 plus I2, because of the junction rule, I1 plus I2 is nothing but total current I. Then you just put those values, simplify, calculate the value of I. Okay, once you have simplified the value of I, from there what you have to do, you have to rewrite the equation to get the final expression in the form of this. Okay, so once you get that, then you can compare and you can write, okay, this is the, instead of epsilon EQ, the total value is there. So you can say this total value is epsilon EQ and this is R EQ. Okay, I hope this helps. I hope you have practiced this, but if you have not practiced this, I request you to practice this. This was a very important question. It came last year as well as it might come in this year also. Okay, this is a very important question. Okay, now arrive at the balance condition of Wheatstone bridge using Kirchhoff's rules. Okay, this is the most important question. This is the most repeated question from this chapter, and almost every year, even alternating year is okay, but almost every year this question is coming. Last year students were in trouble because this question was not asked. Instead of that, Wheatstone bridge was asked in a numerical. So numerical Wheatstone bridge is little bit difficult. We will show you one problem about that as well. Let's see. Okay, so first you have to draw this circuit diagram. Okay, I am not so good at drawing, so I have already drawn this diagram, okay, from your book. So we have used three things. Also you need to remember that you have to use Kirchhoff's rules. Okay, so Kirchhoff's rules are important. So first, what all are there? There is a resistance R1 here, there is a resistance R2 here, the current I1 flowing here, current I2 flowing here, a current IG is flowing here, okay, current I4 is flowing here. Now from the junction rule you can directly write this current to be I2 plus IG. Okay, one more important thing, more work you are doing in the diagram, less work you need to do while solving the problem. Okay, here you can see that, I made a mistake here. So in this junction, if you see, in this junction, I2 current entering, IG and I4 are exiting, right? I2 and IG are exiting, so it will be I2 minus IG. Whereas in this point, at D point, I1 is entering, IG is also entering, only I3 is leaving. So you can write this as I1 plus IG. Even though it does not matter too much, it will be helpful in a sense. After a while you will see. So first, what is the balanced condition? First of all, you need to know the balanced condition at at balanced condition, the current through the galvanometer is 0. So all the hard work that you have done, you can simply put Ig equal to 0, but not at the beginning. So that is what is important. So first we will apply Kirchhoff's voltage law, KVL, or Kirchhoff's loop rule. Okay, Kirchhoff's voltage law at loop ABDA. ABDA. Okay, this is the first loop. So at this loop, what we can write is that, first of all, start with the direction of current. What is the direction? We are starting from A, going to B, coming to D, then going back to A. So the direction of current is very important. So starting with I2, I2 R2 in the direction of the current. So it is positive, I2 R2. Next, we have reached at B. From B to D, again we are moving in the direction of current. Ig is flowing in this direction. So plus, okay, Ig and resistance of the galvanometer, we say that this is G, Ig, G. Now from D to A. Now here we are moving, see, current is flowing in this direction, we are moving in the opposite direction. Opposite direction of current means negative, right? We are moving opposite to the direction of current. We have to complete our loop, right? And in the way, whatever direction of, we have to be single direction. You cannot move in the multi direction. You have to start from one point, reach another point, from there you have to reach another point, from there you have to reach another point. I hope your how to apply KVL is clear in your head. Right, from here to here we are moving in another direction, so opposite to the current. So minus I1 R1, and here no battery is connected. No battery is connected means it will be equals to 0. Right, this is the first equation. We will not do anything for now. We will just keep it as equation number 1. Now KVL at the loop, next we will apply KVL in the loop B, C, D, B. B, C, D, B. This loop, okay, this loop. Again we will start from point A, B and move towards the point C. So point B to point C we are moving in the direction of current. So we are moving in the direction of current means, instead of writing I4, I will write I2 minus Ig. This is the current, right, times the resistance. What is the resistance? Resistance is R4. Okay. Now from C to D, we are moving, our hand is moving in this direction, but the current is moving opposite to that. So it will be minus, what is minus? Minus I3, I3 is I1 plus Ig times resistance. Resistance is R3. Now D to B, again we are moving opposite to the current. So again it will be minus Ig, G. And as you are sure here there is no battery connected, so it will be again 0. Now what you have to do, now you have to put this condition here. At balanced condition, Ig equals to 0. Therefore, from equation 1, this is equation 1, this is equation 2. From equation 1, add inside the equation 1, what you have to do, you have to put the value of Ig equals to 0. So if you put the value of Ig equals to 0, what is left? I2 R2 minus I1 R1 equals to 0, or I2 R2 equals to I1 R1, okay, or I2 by I1 equals to R1 by R2. Okay, so this is the third equation. Okay, now use the same condition in equation 2. From 2 what we can write? See, I2, Ig is 0 times R4, okay, minus I1 plus Ig 0 times R3 minus Ig 0, G 0, so this is 0, so equals to 0, right? So from here we get I2 R4 equals to I1 R3, or I2 by I1 equals to R3 by R4. This is equation 4. Comparing 3 and 4, I2 by I1 from both sides, we can write R1 by R2 equals to R3 by R4. This is the required condition for a balanced Wheatstone bridge. This is the required condition for balanced Wheatstone bridge. Very simple, very easy derivation, one of the most easiest derivation, right? Not as easy as cells in series, but still it is easy derivation. What you have to do, you have to draw the diagram carefully with all the details possible, okay? And only the diagram contains 2 marks, as I remember. 2 marks for the diagram if you detail it properly. Then you have to write the steps. Each step first up to this point contains 1 mark, okay? For deriving these 2 points, again one mark, and the final answer another 1 mark. Total 5 marks is there. So if you answer them properly, you will get full marks, okay? Now let's move on. Now a little bit difficult part where we will be solving numericals. Okay, the numericals, not all numericals are hard. First numerical, for example, is little bit easy. The number density of free electrons in copper is estimated to be 2 times 10 to the power of 28 meter cube. A copper wire of length 3 meter and area of cross section 2 millimeter square is carrying a current of 6.4 ampere. Calculate the drift velocity of electron. Okay, this is the part 1. Part 2 is how long an electron take to drift from one end to the wire of the other end. Okay, so I will give you the basic formulas and how you can solve it. Okay, I am not going to do the detailed calculations because I don't have calculators. You are allowed calculators, but I say don't use calculators if you are preparing for competitive exam. But today you have to use calculators. Now, what is the drift velocity? So drift velocity is, we have seen that formula. If you don't remember this formula, okay, you can use I is equal to NEA VD, and from there you can write this equation. But since I have used this equation twice today, so I remember this formula now. Okay, so practice makes you remember. So if you practice it, easier to remember, and you can just simply put the values. Okay, current is given 6.4 ampere. Number density is given 2 times 10 to the power of 28. Okay, charge of an electron, we know that 1.6 times 10 to the power of minus 19, and area is given 2 millimeter square. So 2 millimeter square, here you have to be careful. 2 millimeter square is nothing but 2 times 10 to the power of minus 6 meter square. Okay, so millimeter, 1 millimeter is basically 10 to the power of minus 3 meter. So when you are saying 1 millimeter square, okay, so you have to square both sides, so it will be 10 to the power of minus 6 meter square. So be careful. So what you have to do here, you have to use 2 times 10 to the power of minus 6. Okay, so using this method, you can calculate the drift velocity. And if I remember correctly, it will come out to be 10 to the power of minus 3 meter per second. Okay, so drift velocity you can calculate, 10 to the powers you can calculate, and then you can find the drift velocity. And then what you have to do, how long does an electron takes to reach? So if you see, the length is not used here in the formula, length is not there. So where it will be used, it will be used in the second part. So this is the length of the wire, 3 meters. Electron started with drift velocity Vd, okay, and how long it will take for it to reach in the other end. Okay, so distance is 3 meters, speed is Vd, how much time it will take. Very easy, S equals to Vd times T, S equals to Vt, so T equals to 3 by Vd. Okay, or 3 divided by 10 to the power of minus 3, that is 3 times 10 to the power of 3 seconds, that is 3000 seconds. Okay, this is the answer. So yes, I have calculated correctly. So correct answer is 10 to the power of minus 3 meter per second, and second answer is 3 times 10 to the power of 3 seconds. You can calculate this, okay, and tell me the answer. Okay, you can use the calculator for each steps, or you can simplify it as you like and tell me the answer. Okay, now next question. This is actually, even though the circuit looks like something else, you can consider this to be a Wheatstone bridge problem. Okay, though even though it is not a balanced Wheatstone bridge, last year also in the annual exam they have given you the Wheatstone bridge problem. Okay, so either it will come like this diagram, or it will come like this diagram. Both diagrams are same. Okay, only thing that you have to be careful about is how you can solve it. To solve this problem, as usual, we will be considering first junction rule, second KVL. Okay, junction rule and KVL will apply one by one, and then we can calculate the current. I am not going to into the details of this solution. This is little complicated. You can try. I will give you the hint. I will give you the proper way to solve it. So first of all, I1 is going here, I3 is coming out here, and they have done the KCL, the first part for you. Even this year question paper also they have done the KCL for you. So this is the junction rule. This is the current through this. Same current is passing through this. The same current is passing through this current, okay, through this resistance, okay. And first we will apply loop rule in this loop. So this is the first loop, okay. Second we will apply the loop rule in this. This is loop 2, okay. And then we will see what is happening. So first I1 into 10 I1. We are moving in this direction, so direction of the current for I1, direction of the current for I3 plus I3 times 5, so 5 I3, okay. Then we will move in this direction. Now we are moving opposite to the current. Opposite to the current means minus 20 I2 equals to 0, okay. What else? Total current in the circuit is given I equals to 1 ampere. So from here you can see that 1 ampere current is coming from here to here, and then it is splitting into two halves. So it is splitting into two halves means we can say that I1 plus I2 is equals to 1 ampere. Okay. Now what you have to do to solve this question, you have to substitute one of the values. Here I will substitute I2 equals to 1 minus I1. Okay, this is the substitution that I am going to do in this problem. So what you have to do, 10 I1 plus 5 I3 minus 20, instead of I2, 1 minus I1 equals to 0. You can simplify, make it an equation. Similarly, you apply KVL in the second loop as well, okay, and then you will get two equations in having I1 and I3. Then you have to eliminate I1 to get the value of I3, and that will be equals to 8 by 9. Okay, if you solve this question, you will get I3 equals to 8 by 9. I have solved this question obviously, but I am not going to do it today. Our lecture is already 1 hour over, so that will be a little bit difficult question. So if you are not super interested in this chapter, you can skip this question particularly. But the third question is easy. Again, another formula based question. So let's see. For copper, the number density of free electrons, again another question based on number density. Okay, number density of electron is 8.5 times 10 to the power of 28 meter to the power minus 3, and resistivity is 1. Now they have given you resistivity. Be careful. Resistivity is given by 1.7 times 10 to the power of minus 8 ohm meter. Calculate the conductivity of copper and relaxation time of free electrons in copper. Take the mass of electron is given, okay, and electron charge of an electron is given. Now first of all, what is conductivity? Conductivity we know is nothing but 1 by resistivity, right? Resistivity is directly given. Resistivity is given as 1.7 times 10 to the power of minus 8. So resistivity is 1.7 times 10 to the power of minus 8. The conductivity first part is done. Okay, 1 by 1.7 times 10 to the power of 8. You can use the calculator to find that value. I think if I remember it correctly, it will come to very close to 0.6 times 10 to the power of 8. Okay, and unit will be, so resistivity's unit is ohm meter. So conductivity you can write either ohm inverse, meter inverse, or you can write it to be 0.6 times 10 to the power 8 Siemens meter inverse. Okay, Siemens is 1 by ohm, short form for 1 by ohm or ohm inverse, but that is fine. Now next, what you have to do, you have to find the resistivity. Sorry, you have to find the relaxation time. To find the relaxation time, what you have to do, you have to remember one formula. Okay, if you remember one formula using the terms, that is number density, then mass of electron, charge of an electron, and conductivity, then you can find that formula. Okay, what is that? Conductivity is given by, so the relaxation time formula is m divided by n is square sigma. Okay, this formula you have to remember. Okay, this formula is given in your books. So m is given by 9.1 times 10 to the power of minus 31, n is given by, number density is 8.5 times 10 to the power of minus 28, charge of an electron 1.6 times 10 to the power of minus 19 whole square, and resistivity we have already calculated, 0.6 times 10 to the power of 8, so not resistivity, sorry, conductivity. So putting these values and simplifying this, you will get the answer. The answer will be, so yes, resistivity is given by 0.59 times 10 to the power of 8 ohm inverse, meter inverse, and the relaxation time will come out to be 0.25 times 10 to the power of minus 13 seconds. Okay, so you can simplify this to find this value. This is a formula based question. Even though the formula is little hard to remember, but you can remember this formula particularly for this problem. Okay, so we have completed the entire current electricity chapter. I hope this will be helpful for your upcoming midterm as well as your final exam. So if you are watching this channel for the first time, don't forget to subscribe to our channel. I will be back with moving charges and magnetism next. So till then, tata, bye bye.